Hi, this is Kenneth Wong, Senior Editor for DE Magazine. SimScale is part of the growing trend to make simulation more accessible, affordable, and approachable to people who have been trained primarily in design creation, not in simulation. Today, I'll check out two of the simple tutorials provided by the company, go through the process myself to see how it works. So, please come along. Since the products are cloud hosted, I don't need to install SimScale software on my machine. I can access it through my browser. This is an advantage if you, for example, want to simulate something on a mobile tablet, a lightweight laptop, or a standard computer when you don't have access to a powerful workstation to meet the typical simulation software demands. The first work I'll try is the simple static stress simulation of this part. The first step is to mesh the geometry, and the interface prompts me to do this, so I'll go ahead and pick one of the mesh types available. I like that it not only provides the mesh choices but brief explanations about what each is good for. This type of information is general knowledge for experts but not necessarily for designers. With the meshing already in progress, I'm going to assign materials, in this case steel for the geometry, then start defining the setup, the boundary conditions. I'm going to specify that there is a certain amount of pressure applied to this particular surface, and this bracket is fixed to something exactly at this point of the hole. By the time I'm done with these boundary setups, the cloud-hosted meshing is done, so I will go ahead and pick the ready-made mesh for the simulation, then initiate a simulation run. Now it takes a few minutes to complete the run, then I get an email notification that the results are ready, so let's go have a look. Just online in the browser, I can look at different displacement, stress distribution, and pressure points. So where the design will likely fail, bend, or break, and if it can stand up to the expected pressures that I've specified. Let's move on. Now I will try a simple CFD, Computer Fluid Dynamics simulation in the tutorial set. Just like before, I will set up the simulation, in this case CFD, to look at velocity or incompressible as classified here. Then I'll start the meshing process. Based on a brief explanation of my choices, I'm picking very coarse, hex-dominated mesh type. This is quite good enough for general design investigation, I think. The next thing I need to do is to assign material, so this time I will assign water volume inside the pump to look at. I'm going to give it 2 inlets with velocities specified for each inlet. Then I will pick the third as the pressure outlet to look at. Now all my boundary conditions are in order. My material is assigned. I have already specified the type of simulation I want to look at. I'm going to pick the mesh that is already ready, and I think we are ready to run the simulation. Fast forward 2 minutes and I can look at the results now. Here are pressure, velocity distribution, and other data points based on my simulation run. Based on my initial trial, SimScale is fairly simple to follow, quite easy to use, and it seems particularly suitable for initial design check to make sure the geometry will work for the intended purpose and there's no likelihood of catastrophic failures. I like how the software gives you brief explanations about the mesh types and the simulation choices, so I, as someone with limited expertise, can get some idea what to choose. I think the interface can be further improved by adding some visual clues to show the applied boundary conditions. As it is now, I sometimes tend to forget whether I've already applied pressure and stresses and fixed points, because a simple glance at the geometry doesn't exactly tell me that I've already done so. I have to look at the simulation tree and the check marks to find out if I've already done that. But all in all, SimScale is a good example of how some vendors are taking the web-based template-like approach to deliver on-demand simulation in a simple interface for a wider audience. So check it out with a test run for yourself. Until next time, I'm Kenneth Wong for DE Digital Engineering. Bye for now.